In this video, we will see how to use dynamic programming to solve the problem of finding contiguous subsequence of maximum sum. This is an exercise problem from the algorithms book by Dasgupta. Let's try to understand the problem statement first. A contiguous subsequence of list S is a subsequence made up of consecutive elements of S. Let's try to break this down. The word contiguous means being next to each other, and subsequence is nothing but a subset of a list. In this example, 15 minus 30 and 10 is a contiguous subsequence because they are next to each other. Whereas when you consider 5, 15 and 40, this is not a contiguous subsequence. It's because 15 and 40 are far away from each other. In simpler terms, a contiguous subsequence is nothing but a substring. Coming back to the problem statement, given a list of numbers a1 to an, we are asked to give a linear time or O of n time algorithm to find the substring that has the maximum sum. Before trying to come up with the algorithm, let's try to work out the solution to the given example on paper. Any substring of the given list should end in one of the elements of the list. First, let's note down all possible substrings that end with each element. For the first element A1, there is only one possible substring, and that's just going to be 5. For the next element A2, there are two possible substrings, 15 and 5 and 15. Proceeding further, for element A7, we have 7 possible substrings. Once we have this, let's try to find the sum of each substring. The sum of this substring is just going to be 5. This is going to be 15. This is going to be 5 plus 15, that's 20. Proceeding further, once we calculate the individual sum, we need to find the maximum sum for all the substrings that end in ith element. Say for example, for ai, which is 1, we only have one substring, so the max would just be the same thing. For a2, there are two possible substrings, and out of these two, 20 is the highest, so the max sum would be 20. For A3, we have 3 possible substrings, all are negative, but the maximum is going to be minus 10 here. I have calculated the max sum in each of the sublists. By looking at the data, we can say that 55 is the maximum sum that we can get with any of the sublist, and that sublist is going to be 10, minus 5, 40 and 10. This is exactly what we need to find with our algorithm. Now let's move on to the algorithm part. The first step is to define a subproblem, which would be a miniature version of the main problem. Here, let's assume that a one-dimensional array S of I represent the maximum sum of substrings that end with ith element. So in this example, S would just have the max values for each element. So S would be 5, 20, minus 10, 10, 5, 45 and 55. Now let's try to see if there is a recursive relation between I and I minus 1th element. Let's assume that there is a 0th element. If there are no elements in the list, then the sum is going to be 0. So S of 0 is going to be 0, and this would be our base case. Let's look at the first number now. Here, S of 1 is same as A1. They are both 5. When you take a look at the second element, the max sum is 20. And this 20 can be arrived by adding A2 with the sum that we have in S1. So I'll write S of 2 as A2 plus S of 1. We can also write this as AI plus S of I minus 1, where I is equal to 2. Moving on to the next one, S of 3. We can arrive this again by adding A3 along with S2. So our initial statement AI plus S of I minus 1 holds true here. Here I is equal to 3. It looks like we have arrived at our recursive logic. Let's just check if this holds true in all the situations. This pattern is observed in almost all the cases. For example, A5 plus S4 is same as S5. And again, A6 plus S5 is same as S6. And S6 and A7 is same as S7. But is the solution complete? Do we already have our recursion? No. How about the fourth element? Going by the same pattern, 10 and minus 10 should have resulted in a 0 here. But we have a 10. Looking into the pattern further, if the max sum was positive, it always had a positive impact on the next sum. In this case, we have a minus 10, and that is negating the value that we already have in the ith element. In order to avoid this, we need to consider the previous value only when it is above 0. That is, when we take S of I minus 1, consider this only when S of I minus 1 is greater than 0. In other words, since our goal is to just find the max sum, we don't want the possible sum to get reduced by any factor because of the previous value. This can be algorithmically written as Si equals Ai plus max of 0, S of I minus 1. And this is going to be our recursion logic. So now we have our subproblem defined and the recursion defined. The next is to define the output. Since ES is going to be an array with all the possible max sum, we only need to find the maximum value in S. So our output will be max of S. The pseudocode for this algorithm is very simple. We have our base case set here. We have one for loop to loop through n elements. This will have a time complexity of O of n. We have an arithmetic operation, it will take a constant time, and overall time complexity is going to be O of n. So here we have a linear time algorithm, and this is our solution.